Welcome back to our next video in Module 2. And so we saw in the last module how to do the first step of exploratory data analysis with a categorical variable, and that is how to inspect and clean the data for a categorical variable. Now that we have nice clean data, we're ready to plot it. And so I'm going to go through some of the steps that I outline in the readings, and there are also YouTube videos embedded in the readings that show you how to do these steps, but I'm going to go through it kind of quickly, and you might want to go back to the readings, find those videos, click on them, and watch them if you want to do it a little more slowly. So first of all, what can we plot with a categorical variable? Well, when you think about it, categorical variables are relatively simple. The only thing we can do with a categorical variable is count the number of times each category occurs in the data set. So if we're looking at, for example, gender, all we can do is we can count the number of males and females. In this case, I was looking at the movie database, and my categorical variable was whether or not a movie was either a sequel or part of a franchise. So the only two possible values are yes and no. And all I can do is count the total number of yeses and the total number of no's in the data set. And we can go ahead and work with those values in two different ways. When we plot the data, we can first of all plot the frequency, or in other words, the counts. So you can see with the movie database, when I plot the number of yeses, there's roughly, say, like 50 yeses, right? In other words, there are 50 movies in the whole database that were either sequels or part of franchises, and there were close to 600 that were not. Very often, we're not interested in plotting counts, and the reason why is it's very difficult to get a sense for how many is in that category if you don't know how large the data set was. So if you said to me, well, how many movies were sequels or part of a franchise, and I said, I'm going to make up a number here, I said 68, you wouldn't know if that's a lot because you don't know how many movies there are total in this database. Human beings in general tend to think in terms of percentages. So when we have large enough data sets, we're going to plot the percentages, and this relative frequency bar chart is going to be what we get, or what we name this plot, when we plot the percentages rather than the frequencies. One of the things we can do is we can order the categories so that they go in descending frequency. In other words, we make the categories that occur most frequently be at the front, and then we go down in frequency. And if I do this, this is called a Pareto plot. And in the videos online where I show you how to make these plots, I discuss Pareto plots and why they're useful. And finally, we can make a pie plot. And again, I would go back, watch those videos in the reading where I discuss pie plots, and you can get a little better idea of when to use them and when not to. And I'll discuss this a little bit more, but I won't belabor the point. Again, frequencies or percentages, it really depends upon sample size. There's no rule written in stone. There are guidelines as to a sample size where you can start to use percentages. So normally, when you start to get around a sample size of 25 or more, we can usually start to plot percentages as opposed to counts. Now, this is just a guideline. This is not a hard and fast rule. It depends a little bit on the percentage of each category. If I have a category that only occurs 0.1% of the time, I'm going to need a very large data set to estimate that percentage well. Whereas on the other hand, if I have categories that, none of the percentages are really extreme, especially extremely small, I can probably use a decent sized data set, maybe of around 25 or so. I'm going to come back to this overview. I want to go through and show you how to make these plots quickly. I did this in the video before, but I'm just going to recap. So this is our data set from IMDb, and I'm going to go ahead and plot the categorical variable sequel or franchise. So I'm going to go to graph. I'm going to do bar plot first. We could make the plot with data or with summary. And again, I would watch the video if you're not sure what that means. I'm going to use with data, choose the variable. And if you've actually watched the video from the reading, you can try this on your own and see if you're doing what I'm doing. I want to plot sequel or franchise. I'm going to go ahead and plot the frequency first. So where you see type, that's where you either choose frequency or percent. And I want to make good labels. So this is really important. Whenever you create a plot of any type, you want the plot to kind of be self-explanatory. A person should be able to look at the plot and not have to read other information from the text, okay? So here I would put whether a movie is a sequel or part of a franchise. And most people will be able to figure out that yes, Y means yes and N means no, but some people would put that explicitly. It couldn't hurt. I'm going to put here frequency on my Y-axis. And finally, for the title, I will put distribution. We're always looking generally at a distribution of movies. I'm going to specify 2015 movies. And I'll put the source TMDB that are either as to whether they are sequels or part of a franchise. And we're ready to go. Now, one of the nice things is you can display the percentages or counts above each bar. And there we are. And I would go ahead and extend this a little bit so that we can read the whole title. And now a person can look at this and they know exactly what they're viewing, okay? And again, counts aren't bad, but you can see that this looks a little awkward, okay? We naturally don't think in terms of counts, How much is 45 out of this sum? Well, first of all, we have to sum it, then take the ratio, compute a fraction, convert it to a percentage. Mentally, we don't do that very well. So what I'm going to do is I'm going to go to Edit, and now I'm going to go from frequency to percentage. And go ahead and compute. And now this makes a little more sense. Okay, I can look at this and I see, okay, it's like, 9 to 1 roughly, or 93 to about 7, if I want it to be a little more precise. And the Pareto plot is just going to organize the categories in descending counts. And I'll let you watch the video and the readings to understand that a little better. But if I wanted to do a Pareto plot, this is already a Pareto plot actually. I would do it by counts descending. I wanted to start with the largest count and go down, and it's already that way. To make a pie plot, I'm going to say with data and do essentially the same thing. I'm not going to have an axis for the pie plot. So everything is going to be in the title. By default, it plots the counts and the percent of total. And there you go. Which plot is best? Well, you have to think about what the purpose of the plot is. If I just want to make the point that there are a lot more movies that are not sequels or parts of franchises, I might choose the pie plot because the difference in the areas is much more distinctive. However, if I want to give a better sense quantitatively of these two categories and how likely they are to occur, I might use a bar plot because I see the actual percentages, so I can look at the numbers and kind of judge the relative heights. Especially when you have a lot of categories, it becomes harder to compare areas for slices of pies as it does heights of bars, especially if they're ordered. So generally, the bar plot or frequency bar plot or relative frequency bar plot is the best choice, especially when you have a lot of different categories. And if you're not sure which to use, I have a nice little table. This is taken out of the readings, okay, and talks about what you're plotting and when you use it. And I would strongly suggest you go back to the readings, watch those short videos if you're not sure how to make these plots or when to make them. Next, we're going to talk about numerical summaries, and then we're going to combine them both and use the visual and the numerical summaries to describe the data set.